Okay, let's get started with our introduction for discrete mathematics. This is all material that's located in Chapter 1 of your book. So let's start with the following question. What is a variable? So a variable is a placeholder used when you want to talk about something that one has unknown values. So an example would be like a system of equations. Or two, you want to be equally true for all elements in a set. So an example would be is there a number x with the property that 2x plus 3 equals x squared. So here, x would be a variable because it has an unknown value. Okay, so now let's define a universal statement. A universal statement says that a certain property is true for all elements in a set. So an example here would be the following statement. All positive numbers are greater than 0. You're making a statement about all of the positive numbers, which is why this would be a universal statement. Okay, let's look at now what is a conditional statement. A conditional statement says that if one thing is true, then some other thing has to be true. So let's look at an example of a conditional statement. If 378 is divisible by 18, then 378 is divisible by 6. So the first condition is 378 is divisible by 18. If that's true, then this other statement, which is 378 is divisible by 6, must be true. So our third type of statement is something called an existential statement. So the definition says that given a property that may or may not be true, an existential statement says that there is at least one value, one thing, for which the property is true. There's at least one time or one object where the property would be true. So for example, of a existential statement would be there is a prime number that is even. So there's one prime number that you can find that would satisfy the property that it's even. Okay. All right, so we have those three types of statements, but now we can kind of combine some of these together. So now let's talk about, I'm not going to define these, we're just going to look at some examples. The first one is a universal conditional statement. So this would be a conditional statement that's also a universal statement. So an example here would be for every animal A, if A is a dog, then A is a mammal. It is a conditional statement. You can tell it's a conditional statement by this if, then. That's usually a dead giveaway for a conditional statement. And then it's a universal statement because we're talking about every animal. And we also have universal existential statements. So these would be statements that are existential and universal at the same time. So, for example, the statement every real number has an additive inverse. It's universal because we're talking about every real number, but then it's also existential because we're saying that there has to be an additive inverse. So one object that has to exist that satisfies the property. Okay, so now let's define what we mean by a set. A set is a collection of objects which are called elements. Okay. So the way we usually write a set is with some curly braces. So for example, 1, 2, 3. So this is a set that has 3 objects and those objects are the numbers 1, 2, and 3. This is a finite set and has a finite number of elements, but you could also have a set 1, 2, 3. I'm going to write dot, 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 and that just means it keeps going on forever and ever. So there's an infinite number of elements in here. And now I want to talk about some notation that we're going to use. So the first notation that you're going to see, these are some new letters maybe that you haven't seen before. R is going to denote the set of all real numbers. Okay, so this includes both rational and irrational numbers, numbers like pi and e. Z is going to be used for the set of all integers. So integers are whole numbers. Q is the set of all rational numbers, or sometimes it's set as quotients of integers. So Q contains whole numbers, the integers, but it also contains fractions, like 1/2, -3/4. And then the last letter symbol we're going to use here is N, which is used for the set of non-negative integers. So these are whole numbers that are positive, that are not negative, not negative. So 0, 1, 2, whole numbers that are not negative. All right, and then when we're talking about sets, we often use something called set builder notation. So it's a notation that looks like such that P of X. Okay, so this would be set builder notation. And this first part is telling you the set of all elements of S. And then this symbol right here, this vertical line, means such that. So you would read this as, this is the set of all elements of S such that P of X. And P of X is some kind of condition that has to happen. Okay, so for example, let's look at this set builder notation. X or such. So this is the set of all. So the first part tells me this is the set of all real numbers that are between such that, remember this symbol right here means such that X is between -2 and 5. So if you want to picture these numbers, you could do so on a number line. -2 to 5. All of the numbers between -2 and 5, but not including -2 or 5. Okay. So now let's talk about a subset. A is a subset of a set B if every element of A is also an element of B. And the way we denote a subset is through the following symbol, A subset B. Okay. So let's look at an example of a subset here. The set 1, 2 is a subset of the set 1, 2, 3, 4. If I check, every element of the first set, so 1, is also an element of the bigger set. 1, and the same thing, 2 is also in the bigger set. So 1, 2 is a subset of 1, 2, 3, 4.